Welcome to exercise 516. This is the one about the cereal and the grocery store shelves. In other words, the sugar content in the box of cereal based upon what shelf it came out in on the grocery store. So I got two questions here. They want for each shelf to find the interquartile range and the standard deviation, sample one. And then based on the graphs you did in exercise 5.8, which you probably don't have in front of you because you've already turned that one in, which summary measures would you prefer to describe the sugar content, the mean and standard deviation, or the 5-number summary? So we're going to do this whole thing on the calculator, okay? So let's get the calculator up here. I'm going to widen this thing out just a smidge for you here. And what we're going to do is, first step is go into stat, go into edit, and I've entered in the sugar contents in L1, L2, L3. So if you haven't done that yet, go ahead and stop this. Take a moment and enter that data into L1, L2, and L3. Okay, now once you've done that, what we're going to do is we're going to go and get the interquartile ranges and the standard deviations for those three shelves. So we're going to go to Stat, Calc, 1var Stat, L1, and that will be for shelf 1. And we get the sample standard deviation for shelf 1 is 4.483. Get the interquartile range. Scroll down here and it looks like it's the difference between Q1 and Q3, which is going to be 8. Okay, so now let's go ahead and get it for shelf 2. So I'm going to go to Stat, Calc, 1var Stats, but this time L2 for shelf 2. Get a standard deviation of 4.129, rounding off correctly. And looks like our interquartile range in this case is going to be, let's see, looks like it's 6 because it's the difference between Q3 and Q1. Okay, so far so good. Let's do it one more time, this time for the third shelf. So Stat, Calc, 1var Stat, L3 for shelf 3. And this time we get a standard deviation of 3.836. And looks like we've got an interquartile range of about, 6.5, okay? Alrighty then, so that's what they asked us to do with the measurements of variation. Now what they want us to do is decide which measurement of variation would be the appropriate one to use. That is, should we use the mean and the standard deviation to describe the distribution for our summary stats, or should we use the 5-number summary? And that's all going to be based upon the shape of the distribution. So what we're going to do is we're going to go in here into our stat plot menu. We're going to turn on plot 1. And what we're going to do is I'm going to do a little comparison graph for you. It's slightly different than what they asked us to do in 5.8, but what the heck, make it a lot more fun, huh? So we're going to turn on the box plot for plot 1, and we'll make that for list 1. And then, I'll show you kind of a cool trick here. If I hit the up arrow, highlight plot 2, hit an enter, that'll take me into the settings for plot 2. I'm going to make plot 2 a histogram, and then I'm going to go down and change my list here again to L1 because this is all for the first shelf. Okay. Now the beautiful thing is I can look at the histogram and the box and whisker plot on the same graph at the same time. We'll have to do a little adjustment of the window to make it look right, but that's okay. So we'll do a zoom, do a 9 for zoom stat. And there's our box and whisker plot and our histogram. And notice the box and whisker plot is now sitting on top of the histogram. So what we're going to do is go ahead and adjust our window here by adjusting our Y max. And we'll adjust our Y max, let's make it, so it's about 7. So let's go for 11, and that ought to make it big enough. There we go. So now notice the box and whisker plot is not sitting on top of the histogram. Just a quick reminder about box and whisker plots. They're a one-dimensional graph. They're only an x-axis graph. The vertical absolutely means nothing on a box and whisker plot. So it totally is cool to put it anywhere you want in terms of the horizontal. It's just, the vertical. It's just the horizontal that counts with respect to the box and whisker plot. But back to the problem here. What we see in both the histogram and the box and whisker plot is that we are skewed positively or skewed to the right. We see that you've got a short distance from the min to Q1 and even shorter distance from Q1 to the median, and then it starts getting all stretched out. Okay, and you see the same pattern here in the histogram, that we've got this distinctly skewed to the right. All right. Okay, let's do this again. Let's do this for shelf 2. So I'm just going to go into plot 1. I'm going to leave it as a box and whisker plot, and I'm going to change it to shelf 2. And then I'm going to do the same thing here at plot 2. Turn that on, leave it as a histogram, and I'm going to change that to L2. Okay, and then we'll do a zoom and a 9, and again the box and whisker plot is sitting on top of it, so we'll fix that by going into window here and adjusting our X max. Let's go up to say 13, and that should be plenty to get it off of there. Maybe we'll go one more, we'll go 14. I don't want it sitting on there. 14, that ought to take care of it. Okay. There we go. Yeah, just barely off it, but good enough. Now, main thing again is that what we see is here's our box and whisker plot, here's our histogram, and this looks like it's distinctly skewed negatively or skewed to the left. And we see the long whisker on the box and whisker plot pointing to the left. And again, look at this very short distance between the median and Q1 and a short distance between the min and Q1. So wait, I got that backwards. Excuse me. That's now we're looking in the other direction. I said Q1, I meant Q3. This is the median in Q3, and this is the max. Okay. So the box and whisker plot has this all stretched out down in the negative direction. So the min has got a long whisker on it. Excuse me. And Q1 has got a long distance before it gets to the median. So in both the first two graphs that we looked at, we're skewed. And whenever you've got a skewed distribution, then your preferred measurement of the summary statistics is going to be the 5-number summary. So for shelf 1 and shelf 2, we would use the 5-number summary to discuss our measurement of center and our measurement of variability. Okay? All right, now let's go take a look at shelf 3. And so in shelf 3 here, which is stored in L3, we're again going to do a box and whisker plot compared to our histogram. The only thing we've got to do is change those all to L3s. Okay, and we'll do a zoom and a 9 again. And we're going to go adjust the window one more time to get that box plot off of the histogram. Notice I'm just changing the y-axis to pull the box plot up a little bit. Let's go with 12 there and see if that works. Yeah, that's looking good. Okay. So now in this case, the distribution, some people may say that there is some skew to the right here, but really it's very minimal. This distribution is approximately symmetric, or roughly symmetric, and we see a roughly symmetric box and whisker plot that goes with it. Now just a quick aside, if the distribution is approximately symmetric, the box and whisker plot will be symmetric. If the box and whisker plot is symmetric, that doesn't necessarily mean that the underlying distribution will be symmetric, okay? So don't get that confused. It's a one-way street there. If the distribution is symmetric, then the box and whisker plot will be symmetric. If the box and whisker plot is symmetric, it doesn't mean the distribution is symmetric, okay? Not a huge thing, but just something to keep in mind. All right, so we notice in this one that the distribution is symmetric. In that case, our measurement of center that was the most appropriate one would be the mean. So our summary statistics that we would use in shelf 3 would be the mean and the standard deviation. Okay, so let's go back and fill that all out back here on the problem. So our answer for part B here, obviously I didn't write down part A, but I'm assuming you copied all that down while I was doing it, is we would say use the 5-num sum for shelf 1 and 2, and then use the mean and standard deviation for shelf 3. Okay, and the reasoning is shelf 1 and 2, shelf 1 and shelf 2 are skewed. Shelf 3 is symmetric. All right, well, hopefully that helps out, and I'll see you all back here for Chapter 6.